Okay. Last thing is about the data viewer. So now we have all the data that is saved in this three separated folder. Let's make some nice plot. If you click on the ES viewer, then it will automatically create a open a web page using the default browser, and it's called okay. I still need to change the name, but so it's a data viewer, and you can it's built based on the Streamlit Python repo. And you can see that the root folder, which is the folder our project is, and then we can select the ES files. For example, we can select all. Then all the data will be like that you treated will be displayed here. And sometimes the name is too long. What we can do, for example, this is the durability data that we tested for 4 days. We can put 0 hour for the legend. You can put 24 hour, 48 hour, 72 hour. And then we apply the labels. Then it will automatically change the labels for you to have a better view. You can also change the file ordering from Z to A to Z, 4 pass, but normally by default is fine. You can also change the color. You can make it with gradients of different options. It's color blind like friendly. And then for the Nyquist, you can choose to plot different ones. So here we plotted the original and truncated. If we delete it, it will be refreshed in real time. So let's delete everything first. So we can choose what we want to plot. We can pull out the original, the smoothed, and the DRT fitted, and also maybe the extended, extrapolated based on the KK method. Then you can see the nice DRT, the impedance spectra displayed with all the legends concerned. And then you have also the option with compare, because sometimes we want to compare the measured data and the fitted data. What you can do is you compare like the truncated versus the original. Then you have the truncated versus original, separated by the hollow circle and the like the solid circle. You can also plot the smoothed versus the truncated. You have the points, which is measured data that is truncated, and the curve, which is the smoothed data based on the KK methodology. You can also plot the thinness fit versus the DRT fitted data versus the truncated, as well as the thinness fit, the fitted data versus the truncated, so the real data. You can also plot the ohmic resistance based on the KK method. As I said, it has a big fluctuation between 0.075 and 0.105. So this is for the KK. You can plot the polarization resistance, ASR, etc. You can also plot the baud. It's the same idea. You put the original, then you have the baud plot here. You can also plot the DRT. So the DRT data based on the truncated. Everything plotted here by default is it uses the real part and the imaginary part, both treated DRT data. And the smoothed, and also if you want to plot the method that we derived from the RBF DRT method, you can also do it. The resistance based on the DRT, you can also plot it. ASR, you can see the DRT resistance, how it evolves. We can also plot the thinness fit plotting. what does a equivalent circuit model looks like? Okay, what is a heat map with different fires and with different parameters, and how it works. So, and then we have also other options that is provided here. So you can play with it with whatever you want. And then we can save the zip file. Under this project folder, it will generate another folder called SOCES figures. And then enter it. You can find a zip file based on the date and time. You extract it, and then you can enter the folder. You can find that all the selected plots here, it's going to be saved here, saved in this folder. If you have an example like this, I would say this plot is more than sufficient. For example, for the line plot for the resistances, this is like dispersion factor for alpha 4, for RQ4. And we can also find the Nyquist compare. What is the comparison between 0 hour, 24 hour, 48 hour, and 72 hours? Which is how it works and how it is plot. So this plot is more than sufficient for project report, European project, national project, whatever it is, but it may not be that sufficient for a well established paper. So again, you're welcome to generate your own plots. So that would be all for this software. I'm quite sure that I have missed something, and if you have any questions, you're welcome to contact me by email or by WeChat, or submit an issue in the GitHub page. So please allow me to close the demonstration part. So if you use the software, I would like to kindly ask you to cite our paper in Applied Energy and also Journal of Power Sources. And I'm also I'm the guest editor for electrochemistry communications with a special issue, reversible solid cell technologies from materials to stacks. You're welcome to submit your work here. And that will be everything for the tutorial today. I will upload the record to YouTube and the Bilibili so that you can revisit the video and to practice and also to solve whatever doubts that you have. So